Review on 7-11. It's called applying polynomial factoring. Basically, when would you apply this process of factoring polynomials, setting them equal to 0 and solving for the unknown? Well, guess what? It's word problems. Many word problems will result in polynomial equations of a degree higher than 1. In other words, an exponent higher than 1. In these cases, the factoring and the zero property or zero factor property to solve the polynomial equations can be used. So let's look at an example. If you turn to your books to page 268, we're going to do the first example. You might want to pause the video till you get your book and get turned to 268 and then turn your video back on. Let's read the story problem. A rectangle with an area of 104 square feet has the length that is 5 more than the width. Find the dimensions. So it's talking about area of a rectangle. Remember, always draw a picture or a chart, something to help you with your story problems. So we know that length times width equals area of a rectangle. It tells you that the area of the rectangle is 104. We're going to let W represent the width. And it tells you that the length equals 5 more than the width. So here's our representations of the information that was given to us. And then it says find the dimensions. So what I'm going to do is I'm going to take this, I'm going to plug in my value for my length. Well, the value was W plus 5. That's my length. The width was represented by W, and they told us the area was 104. So now I have this equation with one unknown. I'm going to go ahead and distribute this W out. W times W is W squared, and W times 5 is 5W. And now you have something that looks familiar to you, that's like we did in the last section. And so we want to solve for W. First thing we're going to do is we're going to get this in standard form and get this equation set equal to 0. So I want to move the 104 to the other side. What happens is this becomes 0. These are not like terms, so you end up with W squared plus 5W minus 104. So now you have a trinomial equals 0. It's now in a form again like you had in the last section. So you're going to factor this trinomial. W times W is W squared. You need to find out what are the factors of 104, right? So you need to go ahead and find those factors. So we know there's 1 times 104. We know there's 2 times 52. We know there's 4 times 26. And if you keep working out, you find out that there's 8 times 13 as we find those factors. And we got to ask which one of these factors. So here we go. This is negative. Our signs are going to be opposite. That means we've got to ask which one of these factors subtract and give us 5. Right? Well, if this is a negative 8 and this is a positive 13, if you subtract those, you are going to get a positive 5. So once you figured you factored it correct, can you factor again? No. Always do your mental check to make sure you factored correctly. Once everything is factored, so I have a factor, right? This times this equals 0. I'm going to take each one of these and set them equal to 0 to find out what W would need to be in order to make this a true statement. In this case, W would be a negative 13. In this case, W would be 8. So, now let's look at our information. Remember, always represent units. When they're talking about units, they said 104 what in the story problems? It said square feet, right? So we're dealing with feet. So we have 8 feet and a negative 13 feet. Always consider or test your answers in context to the problem. Well, you can have 8 feet, but can you have a negative feet? Can you have a negative measurement? Can a length or a width be a negative number? It can't. So it makes sense that this is not going to be a logical conclusion. But this here, 8 feet, does work. So what that means is that the width, this width is 8 feet, and the length is 5 more than the width. So if I take 8 plus 5, I'm going to get 13. So my length is 13 and my width is 8. I have found the two measurements. Make sure you put your units, 13 feet and 8 feet is your answer. Those are the two dimensions. Always go back. Did I answer the question? So our rectangle was an 8 by 13. Now look at 269 at the next example, and let's read it. It says, the volume of a certain box is 20 cubic inches. The width is 4 less than the length. The height is 1 less than the length. Find the dimensions of the box. Remember, we're talking about volume of a cube or a rectangular. So what we're going to then know is that length times width times height equals the volume. That is your formula. It tells you, let's just make some number. Let's say the length will be represented by x. And it tells you that the width is 4 less than the length. Well, if the length is x, then the width is 4 less than that. And for the height, they tell you that the height is 1 less than the length. Well, again, the length is represented by x, so it's 1 less than the length. So here's a representation of our 3 sides. They also tell you that the volume, right, is 20 cubic inches. Okay, so remember, our unit is what? It's in inches. We're talking about inches here. Let's go ahead and plug in our information. The length is x. The width is x minus 4. And the height is x minus 1. And the volume is 20. So now here we have our equation. Everything's plugged in and set up. We want to simplify first. I'm going to take this x times x and get x squared, and x times 4 and get a negative 4x. Bring everything else down. I'm just multiplying from left to right. Now I'm going to use the FOIL method and multiply this. X squared times x is x cubed. X squared times a negative 1 is a negative x squared. Negative 4 times x is a negative 4x squared. A negative 4x times a negative 1 is a positive 4x equals 20. These are like terms right here, so we can combine them. We're going to end up with x cubed, a negative x squared, and a minus 4x gives me a negative 5x squared. All I'm doing is simplifying. Then we have something like we did yesterday. Now this polynomial set equal to some value. We're going to move that value over to the other side so that we end up with an equation that's set equal to 0. So when I move this to the other side by subtracting 20 from both sides, right, I'm going to end up with x cubed minus 5x squared plus 4x minus 20 and this gives me 0. Now I'm writing kind of small here. I'm going to try to spread out a little bit. So now what I have is 4 terms, 1, 2, 3, 4. So we know there's no GCF, we know it's not different squares, we know it's not a trinomial. 4 more terms we've got to group. So I'm going to group these. I'm going to group the first 2 together, bring down my plus sign. I'm going to group the last 2 together. I'm going to continue factoring. Is there a GCF in this one? Yes, x squared. I'm going to factor that out. Bring down my plus sign. Here they have a GCF of 4, so I'm going to factor out that. At this point, I'm assuming you know how to factor. Here we have one term plus another term. Is there a GCF between those two? Yes, the x minus 5. So when I factor out that x minus 5, that leaves me with x squared plus 4. Can I factor this? No. Can I factor this? Always look at this. It almost looks like a perfect difference of squares, but it's not, because this is addition. Okay? So now that we have a factor, we have this times this, we have 2 factors, and the product 0. We are now going to take each factor and set it equal to 0 so we can solve. And this one here. Well, we know in this case, x has to be 5 to make that a true statement. In this case, if I subtract 4 from both sides to solve here, I get x squared equals a negative 4. Technically, you square root those to get x equals, but you cannot have a negative square root, a number with a negative square root. Remember, this is not possible to have that negative. So basically, there is no solution or no real number for this one. So again, in context, you would not even consider this. You would consider this value. I apologize, you did not even see that, but I have recorded this 5 times. I'm not going to record again. What I will do though is I will write this over again just so that you can see it. We have x squared equals 4, or plus 4 equals 0. This now, I'm going to move the 4 over to the other side, so I get x squared equals a negative 4. Square root to solve, I get x equals a square root of a negative 4, but you can't have a negative square root. There is no answer. There's no solution for this at all. So in context, this does not work. So we're going to say that x is 5, right? And the question asked us to find the dimension. So let's look at it. If x is 5, that length, this represents length, then the width is 5 minus 4, which is 1, and the height is 5 minus 1, which is 4. So what we have then is this is our answer right here. Basically, we know that the length is 5, the width is 1, the height is 4. For what? In inches, right? So this is 5 inches, the height is 4 inches, and the width is 1 inch. Okay, we found our dimensions of our box. Let's look now at page 270C. I'm going to work it 2 different ways. Here's the first one. Let's read the problem. The problem says find 2 consecutive odd integers whose product is 1 less than 6 times their sum. Well, before we do that, let's just talk about story problems with consecutive integers. If I said all consecutive integers, that would be like 1, 2, 3, 4, 5. If I said odd integers or odd consecutive integers, then it would be 1, 3, 5. And if I said even consecutive integers, it would be like 2, 4, 6, right? If I let x represent the first integer here, assuming it's that. What would I use to represent the 2? Well, it'd be x plus 1, right? Because 1 plus 1 is 2, right? X plus 1. How would I represent this one? X plus 2. Because to go from 1 to 3, I had to add 2. So these are representing these numbers. If it's odd, and I said, okay, well, this is x, how do I go from 1 to 3? Well, you add 2, right? So the representation of 3 would be x plus 2. And how do I go from 1 to 5? Well, it would be x plus 4, right? Because 1 plus 4 is 5. So these are representation of these numbers. If I was talking about even consecutive integers, then this would be x, this one would be x plus 2, and this one would be x plus 4. Notice that these representations here are the same, whereas here it's not, right? So let's look at our story problem. It says find 2 consecutive odd integers. So it's wanting the odd integers. So if I let the first one be represented by x, then the second one would be represented by x plus 2. So here's a representation of my 2 consecutive odd integers. It says find 2 consecutive odd integers whose product means you're multiplying. So I'm going to go x times x plus 2, whose product is 1 less than 6 times their sum, the sum of these, right? If I add these together, I get 2x plus 2, right? So that's their sum. Now I have an equation, right? Something equals something. So what I need to do is go ahead and simplify everything first. So I'm going to take x times x, I get x squared, and x times 2, and I get 2x equals, and here I'm going to take 6 times 2x, and I get 12x, and 6 times 2, I get 12. Bring down your minus 1. I can simplify again because 12 minus 1 is 11. And now I've got everything simplified. I want to get everything to one side so it's set equal to 0. So I'm going to subtract 12x from both sides. Make sure you line them up with like terms. This gives me 0 here, but I still have an 11. This gives me x squared, and this gives me 2x minus 12x is a negative 10x. I want to bring the 11 to the other side, so I get x squared minus 10x minus 11 equals 0, right? Because if I subtract 11, I'm going to get 0, right? So now I have this trinomial equals 0. I want to factor it. I'm going to factor it. See what I get. I have x and x. Factors of 11 is 11 and 1. This is negative, so I'm going to have a positive negative, but I want to make sure I get a positive 10. So I want to make sure that, or negative 10. So make sure the larger number's negative and the smaller one's positive there. Do your check step, your mental check step, check your middle term, make sure you end up with this trinomial. Ask if you can factor again. We can't. We now have this completely factored and is set equal to 0. So to solve for x, we're going to take each factor and set them equal to 0. And then we're going to solve for x. In this case, x is a negative 1. In this case, x is 11. So we have two values. Now what was x? Remember, x represented my first odd number, right? So these here were my first odd number. These right here represent my first odd number. So now I need to find out what is my second odd number. Well, remember, my second odd number, remember, was x plus 2, right? So if x is 11, and I plug that in, then 11 plus 2 is 13. But if x is a negative 1, then a negative 1 plus 2 is a positive 1 when I plug that in. So my first odd number is 11, my second one is 13, or my first odd is a negative 1, and then this one is 1, right? So we've got these two numbers, two types of numbers, two solutions, right? It could either be 11 and 13, or it could be negative 1 and 1. Now that, we solved this problem by letting the first represented be by x. The book does something a little different. They introduce you to another way to work with consecutive odd integers, or consecutive integers. And so I'm going to do that same problem, only we're going to not start with x. Let me just talk about it a little bit before we do it. If I have x and I take 2 times x, 2 times any number, I don't care what number you plug in for x. When you multiply it by 2, you now have an even number. So this is going to be an even number no matter what. No matter what x is, this is going to give you an even number. So if I was to say, let's say that this 2x represents the 2, what would I do to go from here to here? If it's even, to go from 2 to 4, I'm adding 2. So this would be 2x, whoops, doesn't matter if it's even. I'm just going to make this 2x. To get here would be 2x plus 2. This one would be 2x plus 4, and so forth, if we started with that. Now what if we started with 2x here on the odd? Well, remember, this is an even number. So let's pretend it's 2, right? So if this is 2, how do we get an odd number? You add 1, right? Because it's even. This one will always be an even number. So to represent this odd number, it would be 2x plus 1. To represent the next odd number, it would be 2x. If we're going from here, it would be 2x plus 3. This would be 2x plus 4. Okay, so or excuse me, 2x plus 3, 2x plus 5. Sorry about that. All right, and this would be 2x plus 6. So you can see this has got a 2, 4, 6 pattern if we're using the 2x. This has got a 1, 3, 5 pattern if we're using the 2x. Now there's pros and cons by using it this way. The one pro is that 2x is guaranteed to be even number no matter how you start. The con, or the drawback, if you want to say, to using this to represent is that 2x or x is not your first number. You remember here, x was our first number. In this case, the 2x or x will not be your first number. So I'm going to work that same problem, only I'm going to use some different representation just to give you an idea why the book is showing you this. I'm not sure why they chose to do this. Like I said, there's more than one way. You're going to end up with the same answer. But let's go ahead and do it. So it says, find 2 consecutive odd numbers. Okay, so we've done this 2x. Our first odd number is going to be 2x plus 1. And our second odd number is going to be 2x plus 3. So as you can see, this is our first odd and our second odd. It has nothing to do with the x. So here is a representation of the first and the second odd consecutive integer. It says whose product is, all right, so we're going to take the product, 2x plus 1 times 2x plus 3 is 1 less than 6 times the sum. So I'm going to add these together, right? So that would be 2x plus 1 plus 2x plus 3. And now we're going to simplify. Well, 2x plus 2x is 4x. 3 plus 1 is 4. Because remember, you always simplify inside the grouping symbol first. And I'm just going to work this left side first, or right side first. Okay, so we've simplified inside. Now we do multiplication before subtraction. So I'm going to take 6 times 4x, and I'm going to get 24x. And 6 times 4 is 24. Bring down your minus 1. And then 24 minus 1 is 23. So you're going to end up with 23. And I've now simplified the right side. I'm going to come over here and I'm going to simplify the left side. I'm going to use that FOIL method here, right? I'm going to do FOIL. 2x times 2x is 4x squared. 2x times 3 is 6x. 1 times 2x is 2x. And 1 times 3 is 3. But this 6x and the 2x can become 8x if you simplify. All right, so we've simplified the left side. So now everything's simplified. Our goal is to get everything to one side so it's set equal to 0. So what I'm going to do is I'm going to subtract 23 here because that will give me 0, which means I need to subtract 23 from this side. I'm also going to subtract 24x from this side because that'll give me 0. So this all gives me 0 here. And I got to subtract 24x here. So 3 minus 23 gives me a negative 20. 8x minus 24x gives me a negative 16x. And then you have that 4x squared you need to bring down. Now that we have everything in the standard form, it's all reduced, set equal to 0, we now have a trinomial that we can factor. First thing you ask yourself when factoring, is there a GCF? Yes, there's 4. So I'm going to factor out 4. And then we look here, and we're going to factor what's inside the parentheses. This is x times x. 5 and 1 are factors of 5. This is negative, so we're going to have a positive and a negative. Make sure you put the sign in the place so that you get that same middle term. Can't factor anymore. So here's our 3 factors: 4, x minus 5, and x plus 1. We don't need to concern ourselves with this because there's no x value. So here I'm going to say x minus 5 equals 0 and set this one also to 0. I get x equals a negative 1. I get x equals 5. Now, in this case, you just found out what x is. X, what is x representing? All right. X represents nothing. What represents this first number? 2x plus 3. So we're going to write this way. The first number was 2x plus 1. The second number was 2x plus 3. I'm going to substitute in the value of x. When I do that here, I'm going to get 2 times 5 plus 1, which is 10. 10 plus 1 is 11. On this one, I'm going to plug in. I'm going to get 2 times 5 plus 3, which is 10 plus 3 is 13. So our numbers is 11 and 13, our first odd and our second odd. But what about this one? Let's test this one. Again, if I plug in the negative 1, I'm going to get 2 times the negative 1 plus 1, which gives me a negative 2 plus 1, which gives me a negative 1. And here I'm going to plug in a negative 1 plus 3. So that's going to give me negative 2 plus 3, which gives me a positive 1. Now, oh, sorry. I'm so sorry you didn't see all that. But basically, we've got the answer. I'm going to plug this 5 in and solve. And I'm going to plug in 5 here and solve. So I get 11 and 13 as two possible answers. So 11 and 13 work. Or when I plug in the negative 1, I get negative 1 and negative positive 1. So here's two consecutive odd integers that work. Here's two consecutive odd integers that work. And so we got the same answer that we did previously, no matter how you set up the problem, whether you use this as 2x or whether you did it with x, you got the same consecutive odd integers. And I don't care what odd integers or how you set up your consecutive integers to be. I'm sorry you didn't get to see the last part of this in the written form, but I have recorded this 5 times, and I'm not going to try it again for the 6th time to be successful. So you can just study your example in the book. It's right there on page 270.